Hi, welcome to the first episode this week of Golden Path to Spring One. So basically, if you haven't heard of Spring One, it's a conference that we have for Spring folks. It's going to be happening in person this year in Vegas in August. So there'll be a little screen at the very end of this to tell you a little bit more about that. CFP is still open for a few more days. So submit stuff to that and to VMware Explore. Thanks everyone for coming. If you haven't been to any of these before, we have them pretty much every single Tuesday and Thursday. So come join us. If you want to see some of the previous episodes, you can just go to tanzu.tv and there will be things for under Golden Path, and then there's a bunch of other stuff. All of the videos for them, including today's, will be up on a few YouTubes and also on Twitch as well. Today we have João and Vinay, and they're from Kobalt Music, and we'll be giving a talk on tuning the streams for music artists. Could you tell me a little bit about yourselves?
Sure. Hi. So my name is João. I've been with Kobalt for 3.5 years, more or less. My background is software engineering. I mostly worked with the Java ecosystem over the years, and for the past maybe 5 years, I've been a manager. So I'm an engineering manager currently at Kobalt.
Hi, I'm Vinay. I've been working with Kobalt for almost the same time as Joe as well. My background is Java engineering, and I'm working in a capacity of technical architect at Kobalt at the moment.
Awesome, cool. Yeah, so I'm excited to hear about this. I love music. It is I don't know how I would go through my days without music in some capacity. So yeah, let me share your slides. Oh, and one other thing, I was just told that the CFP for the conference is extended until mid-April, so still get it in ASAP.
Cool. All right, I guess we can take it away. So hi again, thanks for joining. So today we'd like to talk a little bit about Kobalt, our company, a little bit about the music industry as well and how it operates on a very high level. Speaking a little bit about our history with technology, and then I'll hand over to my colleague Vinay, who will do a deep dive on royalty processing specifically and what we've been doing around that space in terms of replatforming, and also how Spring has been helping us do that. So just talking a little bit about Kobalt, I believe Kobalt Music is not very well known when compared to the majors like Warner and Universal, but we actually operate more or less on the same level. We share a very similar market share, and I think you can see from the brief sample of our artist roster that we also manage some pretty big names. This is just a very small preview, but in essence, we have a really, really rich and high visibility catalog. And when it comes to the music industry and how we operate in it, very briefly, because the industry is actually quite complex, and depending on what you do, things can vary wildly. But in essence, you have two flows of information. You have the production of music, and then making sure that that music is available for consumers. So you can see that in one direction from bottom to top here. And then you have a second direction, which is whenever music is consumed, there is royalty data produced normally, and then we have to ingest that royalty data. We have to receive money, and then understand who should be paying, who should be paid, how much they should be paid, etc. So Kobalt's mission here is actually trying to make this space a little bit more fair for artists. And the way we try to do this is try to make things as transparent as possible, and also as fast as possible, because this flow of information sometimes can take a long time. Specifically, when we're talking about payments, it can take a long time for artists to get paid. And also it can be really hard for them to understand where the money is coming from. And this can be really valuable information if you think of an artist planning like a tour, or where they want to launch the next album, etc., that sort of thing. I think it's also clear that this is a very again, it's a very simplified version. There can be a view. There can be a lot of layers in between producers, artists, and consumers, and so it can be really challenging to operate in this space. There is also industry-wide a problem of poor data flowing through these different layers. There's lacks of standards and things like that. And what happens is that a lot of the times the information gets misinterpreted or just gets lost. And ultimately, this really can have an impact on the artists specifically, because we can be missing on money that they are owed, and things like that. Which in today's day and age, it's a really poor place to be in, really. So specifically about Kobalt and how we try to improve the space, we have two main business units at the moment. We have AMRA, which is there on the diagram, which is a collection society, and then we have a music publishing business unit, which is the red K there. So obviously, by occupying more than one layer, we try to take advantage of this and try to make sure that the information in-house flows as fast as possible as well, and we can take as much advantage as possible from all the information that we're producing in-house. I think this is it for a brief overview of the industry. For the purposes of this presentation and what Vinay will be deep diving more, we're going to be focusing on the downward flow of information. So whenever music gets consumed and royalty information is produced, what is happening on our side in order to make sure that artists are paid. So how are we ingesting and processing that royalty data? And just to cover a little bit of our tech history before we dive into the current platform. So Kobalt is not a new company. It exists for 20 plus years. And like most companies, we've started with a monolithic system. Basically, that monolithic system was made of this big Oracle database. And we have traditionally a Java Swing UI application on top, which is very much still in use for day-to-day business operations, so used internally mostly as a back office application. And we also have externally facing a portal and mobile applications that the artists can interact with. As traditionally, this type of system requires a lot of manual testing. In our case specifically, we have a lot of logic in Oracle, for example, in the form of PL SQL, which makes it really hard to have automated testing. So this leads to very long release cycles as well. And then with all the downsides that you get over time as things start to grow and grow. So today it's really hard to maintain this system. It's also really hard to hire or attract the right type of talent because we're dealing with old technologies here. And also the fact that we have so much dependency on one single database for so many critical operations, it means that things can go wrong really quickly because you introduce a bug or some bad deployment, and then you can bring the whole thing down, and that can just have a devastating impact to the wider business. Specifically in our case of royalty processing that we're going to talk here, we've also hit some really hard limits a few years ago. For example, in 2018, we processed around 1 billion royalties. In 2020, it was around 2 billion royalties. This was a 100% increase in a couple of years. And I think it was around 2019 that this Oracle database started to struggle with the royalty volume and the time we had to process all of it. Today, luckily, we are in a much better position due to the effort of lots of the teams in our engineering departments and the work they've been doing for the last couple of years. We're still depending on the Oracle system to a certain extent, but we have successfully replaced some of these critical components to a newer tech stack, royalty processing being one. And for example, we can say that today we process around 80% of our royalties in our new pipeline that runs in a different infrastructure. We use AWS mostly for it. We also can do this processing a lot faster. Before we had around 400 royalties per second on this Oracle database. Today we can hit 4,000, and we think that's not really hard limits. We can scale more if we need. So this is really good, not just to cope with the immediate pressure, but also future-proofing the business for growth. And another strategy that we've employed was to try to have, in some areas at least, an event-driven architecture. Because to give you a concrete example, there's a lot of things that go into play when we process royalties. And one example, for example, is we need to take into account the kind of contracts or agreements that artists have with us. And these agreements actually change a lot. And whenever there's a change in a specific agreement, sometimes royalties need to be reprocessed to take into account the new rules. And this used to have to be a manual process. It still is in many ways. But one idea that we have for the future is that we can start having our new applications to react to these events. So whenever an agreement changes, we can immediately know which royalties need to be pre-processed and just do that instead of waiting for any manual intervention. So this is it's a journey. We're not finished by any stretch, but we've come a long way. And I think another area that's really interesting that we're starting to invest in is because of the bad information or the poor metadata that I've mentioned earlier that exists across the industry, going through all these different layers. We're also starting to employ some new machine learning techniques to try to recoup some of the missing information, and that's really promising because it means that we are able to deliver more for our artists than we could normally when dealing with data in the more traditional sense. And then obviously we have all the good engineering practices that come from rebuilding some of these components onto a new tech stack, like it's listed there. I'm not going to go over those, but that's also a really good thing to be able to achieve as part of this. So this was it for a brief snapshot of Kobalt Music, the industry, and a little bit of our history in terms of technology. Now I'm going to hand over to my colleague Vinay, who's going to walk you more specifically about the royalty processing side of things, and also the role that Spring has been playing as part of this journey, essentially.
Thank you, Joe, and thank you, listeners, for joining us today for this talk. Like Joe already mentioned, so we had this ancient system which has got lots of batch processes in place for calculating the royalties. Obviously, we have this three-tier system from 2 decades old where we got Swing UI and talking to a Tomcat server and storing everything into the Oracle database, right? So to take this monolith out into the cloud, we had we were looking at which places will be more effective to take them out first, because we're not planning on taking the whole system built in 2 decades over cloud all in one go, not practical. So yeah, we decided the part that makes sense to go best was the royalty calculation area, wherein we are receiving millions of royalties, and we are generating billions of payments over there. If we take that process out into the cloud, we can free up a lot of space in Oracle database, and that will give us a real boost to have make a good impact in terms of performances with royalty calculation. So yeah, we went down the canopy of having an event-driven architecture. So Kafka being our backbone to begin with, and thinking of putting those processes as a microservices which are interacting in a choreography way. So that once that system design was put in place, we needed next 2 ingredients. What does our microservices look like? Which is the first area. How do we? What is the architecture of the services that we're going to build? Now, learning from our old systems, we have decided that we want to keep our application logic far away from all the infrastructure view. So the one thing that we wanted to go down the route was making use of the explicit architecture, which is basically Herberto Gracia's piece of work, which is kind of like putting together understanding of all the architectures that we see on internet these days: the clean architecture, hexagonal architecture, port and adapter architecture, event-driven command query. So that is his view. There's a link shared on to the presentation, which gives you a further big reading about how he sees all this thing put together in a certain way. And it made ultimate sense for us to kind of like have a clean architecture in place. So we were inspired by that, and we thought we would try to put a clean architecture into our microservices which basically on the next slide means we have to separate out our application logic from the systems that are going to invoke our application logic, and the systems that we'll be using to fulfill our purposes, which is basically the driving adapters, which are talking to our application logic. And then application logic needs some database, some queuing infrastructure to fulfill its requirements. So we would like to keep them completely separate from application logic. And application logic should not be dependent on those two areas. Next, what we did was we decided about how are we going to structure our application logic. So we broke them down into the domain driven design, where we have domain entities, we have domain services, and most of our use cases are developed using an application layer, which is sitting on top of those domain services and interacting with them. While interacting with things like queuing system, we also needed some command handler, which our driven adapters will be able to invoke. So we had command handlers and query and event handlers, which will be invoking our use case in turn, which in turn will be talking to our domain services. So the interesting part over there to look at is the driving adapter is naturally dependent on the application logic because it is calling the application logic. But the application logic is invoking the driven adapters, but we didn't want our application logic to be dependent on their code. So there was an inversion of dependency, as in like the driven adapters were injected into the application logic as and when they were being called. So obviously that was the first ingredient about what the architecture of microservices look like. On the next slide, we have the second ingredient, which is basically what frameworks do we need? How can we leverage all the things that has already been done into the industry to kind of bring it to us and just focus on writing the application logic. So when we put these two things together, on the next slide, what we came up was our template service. Our template service came up with lots of Spring Framework goodies, which were able to talk to our infrastructure. And because we were event driven, we don't as of yet have lots of user interactions with this new system that we are building. So users are still interacting with the legacy system, but we extract the data out of the legacy system using change data capture process, and we start our process from that point on. So basically, what we have in place is Kafka as a backbone, which triggers our choreography of all this application services that we have put together. And we also have mixtures of databases to hold the state of our events when they're passing through. And we also have notifications and alerts and observability, all the things that Spring provides out of the box. On the next slide, what does this, so we have these components. So we have decided our architecture, we have decided our framework. So what does our service looks like? This is the high level of, at the center of the diagram, you can see we have got an application core, which is made up of the domain services, domain entities stuck together. And they're just interacting with the domain related components. On the left and the right hand sides, we've got event bus adapter, which is our driving adapter, which is reading from our Kafka topics and invoking application logics. And on the right hand side, we have query and command adapters, which are basically our driven adapter, which are giving us more rich information that is needed in order to serve the business and store the state of our domain entities into the databases. On to the next slide, we go a little bit deeper into the control flow of how this is interacting using Spring components in place. So we as a developer in our team are focused purely on writing those green boxes, which is basically we just implement our application services, our domain services, which are made up of command functions, query functions, or the functions which are implementing our application services. But a lot of boilerplate code, a lot of infrastructure related code has already been taken care by the Spring framework. All we have to do is just configure the Spring framework in such a way that it gets to invoke our functions, and it takes care of lots of exception handling and those kind of things for us as well. So the typical flow on that diagram, if you see at number one, the Kafka client, which is embedded into the Spring Cloud Stream K-stream binder, is basically responsible for using the Kafka client, reading the input from the Kafka topic, deserializing that message if it is in some binary format, and then using the consumer is passing or invoking the functions that we have written, which is when the whole process that we have implemented starts picking up that particular data. And then eventually either we send the output message, which is a valid message, or an error message, as in a business error message, to the producer, which is then written back onto the output topic. Any of the deserialization errors or serialization errors are configured within Spring to be kind of like either log them out or write them to DLQ. We don't have to write even a single line of code to do that. We just have to configure them into the application YAML property files. So that's the beauty of embedding Spring frameworks into our services, which makes writing our code much more focused and much more easier as a developer. On the next slide. So what does our service now looks like? So on a high level, this is what most of our service functions. So each of our services are further broken down into the functions. A service can have multiple functions, and those functions can be can be implementing the command handler, or can be implementing query handler, or they can be implementing the event handler. What does it look like? It takes in a stream of messages coming from the Kafka. It goes through this command chain, which is basically the source, various processors within the streaming, as in like filtering, aggregation, and eventually at some point in time, after it has done the filtering and aggregation, those kind of things, it will invoke a particular piece of business logic, which is where the center of the function comes into the play. So we are using mapstruct to convert the binary formats into our entities. And then we are using Weber validation to identify the business entities good enough to proceed. And then eventually we invoke our core functions, which are written into the application core area, like we saw previously, which then does what it needs to be doing in terms of business processing and returns back a domain entity, which is on its way back, just converted to the binary format and written back down into the Kafka topic. So these are typical, all the functions that we are writing implements exactly the same way. And on the next slide, it just shows that how readable the code becomes. This is one of our simple function that we have implemented. And we have got like hundreds of functions like this at the moment, which are basically taking an Avro mapper on line 134. As you can see, it has got an Avro mapper, which is mapping the incoming message to the entity. On the next line, it is then using the validator to validate all the business rules are passing for that particular entity. And when it is good enough, it's invoking another function, which is basically the processor. This is where the business logic lies. So all our identified royalty processing logic is in that identify royalty processor. And eventually, when it returns an output object, optionally, we also check the output entity is good enough to be written out. And then finally, it maps to the binary format and goes out. So yeah, all of our application logic is just kind of compositions of all these Java functions together. It becomes much more easier. On the next slide, putting all of this together now, the scale of our infrastructure is quite big, as in like, just to give a quick example of one of the song, which has got 5 writers, and it includes 9 musicians, and it is recorded in 11 different versions, and it has got 8 official remixes. So you can see one particular song can have that many artifacts, and we are receiving royalties for each of those artifacts, right? For each official remix, we are receiving a particular royalty, and that royalty then needs to be distributed among like 9 musicians and 5 writers, and we are collecting them from hundreds of territories. And if that song is played like 170 million times by 3.2 millions, all of a sudden you can realize that one particular song can generate millions of royalties, and up to like millions of pounds that needs distributing among those 14 artists, 5 writers, and the 9 musicians. And we have a catalog of millions of such songs. So it's quite a huge scale of data that is coming through this. And the way we work this out is our legacy system sitting on the top is kind of like we are extracting data out of that. And then we have this various services implemented together. And as you can see in the middle, they're talking over the message bus by passing the events to each other, which eventually then realizes the payments for us and sends it back to our legacy system. And that's how we save lots of data that we didn't have to write into the legacy system by processing them into the cloud. On the next slide, we have had some of the challenges, conceptually it was quite right to adapt to the hexagonal architecture, but there is no right way of putting together. For example, do we package our core as a single jar file, or we package our code as a single mono repo? All of those decisions that need to be made as a team. It wasn't kind of like out of the box of how you structure your code. You have to go through some experimentation to make it work for you. And we had our own rounds of experimentations with that, and we got the balance right. And after 2 or 3 attempts, we got our services working correctly in the way that made sense to us. Obviously, there were some architectural challenges that we faced. For example, writing to the database and writing to Kafka, we cannot have, like traditionally we used to have 2-phase commit protocols to kind of like ensure the atomicity between 2 distributed system, which is not the cases with the Kafka in place. So we had to kind of like devise some sort of patterns based on transaction outbox, or based on CQRS, or Saga patterns to kind of like come to an eventual consistent state, so that we realize that the 2 systems where the data is stored are both in sync. So yeah, we had those little bit of architectural challenges to deal with. On Spring framework level, we didn't have many challenges over there, other than a little bit of learning curve in the team in order to understand all the frameworks like Spring Cloud, streams, and how they work underneath, and what kind of opinions that they've made on top of Kafka Streams API or Kafka API. How are they using consumers and producers? Little bit looking under the hood was required. But other than that, the only painful point was around the application YAML file, which has got various levels of binding, like Kafka string bindings. There is a Kafka binding, and then there is a function binding, and how the override between those bindings work was a bit confusing. But that was mostly prior to 2.6.0 versions of the Spring Boot. Post that point, it became a little bit clearer, but we still have those multi-level binding, which sometimes confuses to the new developers. And the last part we had challenge around was because of this asynchronous nature, testing the positive test cases, as in like we've sent the message and we are expecting the message to arrive, was good enough. But testing the negative, like if you're sending a wrong message, if the message is not good enough, to ensure that it is not arriving onto the end topic, those kind of scenarios were taking a bit longer to kind of like realize, or getting a good guarantee that it actually hasn't happened, because you have to kind of like have to put delays in your integration test, which then makes your integration test run much slower than you would have liked to, especially when you got hundreds and hundreds of integration tests. Everything is working fine across all the services. So yeah, those were the higher challenges, but there were also big wins from adopting to this architecture and you making use of those Spring frameworks. The primary was the observability. It gave us, prior to this architecture, we didn't have much view into how things were going inside our batch processes. But with this event-driven and microservices and each services being observable, we were able to kind of like use the actuator to our full best capacity to identify how the system is behaving. And we were pushing lots of custom metrics to the data dog using the metrics framework provided by the Spring Boot, which gave us quite visibility into everything that was going. And adapting to a functional programming language gave us much more easier way to decompose our logics into smaller bits, and we were able to test them out individually. The other good things were the Spring documentation and the testing experience based on the test containers, Avatility and Spring Boot test. It kind of like made our jobs much more easier, much more readable. We were able to write much more readable tests, which made complete sense from understanding what the test is testing. It didn't have lots of boilerplate code around consumers and producers, which will convolute the testing logic. Though the documentation was quite there, like 80% of it was there, but when we needed some advanced help, the documentation was falling short for us. But during that time, we used to reach out to Stack Overflow and Gitter, and the Spring community was quite responsive. The amount of time we have put questions and the responses we have got is usually very quick. It's not even like next day. Sometimes it is even within an hour that you just get the response back. So it was kind of like really great to kind of like have that support from Spring community to do a really good job out of this. That's pretty much it. Back to you, Joel.
Yeah, thanks, Vinay. I know I passed too quickly, but yeah, if you're interested, I guess you can go back on the presentation and just check our career sites if you're ever interested in helping us on this journey.
Awesome. Thanks, you two. This was, I like how it was like all the different parts, like the way you went about things, and then like the wins at the end. Those are awesome.
Leave the good bits for the end.
Switch it back to regular. There we go. Yeah, we didn't have any questions, but that's because you, like, I feel like it was a lot of being able to just like follow along of what was the pathway that you all were working on, which is, it's really cool seeing like these like stories of like, not just like, oh, here's a thing, how do you like go do this, go do that, but like actually hearing a story of like what people have specifically done themselves and it working out for them.
Yeah.
I mean, it's definitely an evolving process, but yeah, like we try to highlight it, there's been a lot of ground covered already, which has been really good.
Yeah, I mean, none of this stuff is what I would say easy.
Yeah, no, it was not easy at all, but I think it was quite straightforward in terms of to achieve our goals, because lots of things were already done and they were like put together. So yeah, it made the job really easy, but yeah.
Yeah, it makes it sound easier to the people who just get to listen and be like, oh, cool, you did these things, and not having to actually be the person that's like, oh, I have to do this and this and this. Like the whole just like process of migration and everything in general is just like, it's not simple. Like, I mean, just like dealing with the talk of like going from just like having Kubernetes to being able to do things in production. It's just like all these things that you may have to do or not do. And it's just all these things are a lot. And that's why engineers, yay.
I mean, and when you're dealing with such a big legacy system like lots of companies have, you really have to be diligent about the challenges you take on, because you can't just do it all. There's no time or there's no resources. And so you have to be really focused on things that you decide to do, have a good justification for it, and then keeping that in mind so that you don't deviate and try to solve all the world's problems.
Yeah, and like obviously there for some things there are guidelines, but there isn't like necessarily a specific rule to be able. There's not like here's this thing, follow all this, and it'll be exactly what you need for every single person and have it work out.
Yeah.
So yeah, thank you all so much for doing this. I appreciate all the people who have come on, both for speaking and for everyone who's been attending. Again, if you want to watch this later, or if you want to see any of the other ones, you can go to tanzu.tv and go through any things on Golden Path, and you'll be able to see videos for all the things, including this one, immediately after this one stops streaming. So yeah, thank you so much, everyone.
Thank you.
And
Thank you.
a few housekeeping things. So if you are wanting to learn more about Spring, which is probably like why you are attending this stream, for instance, there are other things as well, such as Spring Academy. There are a bunch of different courses that you can go through and learn more and basically follow along for the people who want to do something specifically hands-on. We also, as I mentioned earlier in the stream, but in case you missed it or whatnot, we are having Spring One. It is co-located this year with VMware Explore in Vegas. It's between August 21st and 24th. CFP is open until April 14th. Please submit something. It'd be great having you all there. So yeah, thanks again, everyone. And there's another stream on Thursday, so go to that as well.